If the position vectors of the points A, B, and C are given, then we need to show that the 3 points are collinear. Okay, let us begin. So let's try to understand it graphically first. So here we have 3 points. We have point A, point B, and point C. We are also going to consider another point O, which is going to be the origin. It's the origin of some coordinate system. Now, with respect to this origin, we can define the position vector of point A, B, and C. All we have to do is join O and A, O and B, and O and C with the help of a directed line segment. So now, let's define the position vector of point A, which is given by the vector OA. So we're going to represent it by the vector I cap plus 2j cap plus 3k cap. Then position vector of point B given by OB vector, this is going to be represented by negative 2i cap plus 3j cap plus 5k cap. And then position vector of point C, that's OC vector, this is given by 7i cap minus k cap. Fine. Now what we'll do, we'll join point O and A and B with the help of a vector going from A to B. So here AB vector, this is defined in terms of the position vector as OB vector minus OA vector. That means position vector of the final point minus the position vector of the initial point. Now we have OB vector given by negative 2i cap plus 3j cap plus 5k cap. And from here we're going to subtract OA vector. So that's I cap plus 2j cap plus 3k cap. So this is going to be equals to negative 3i cap plus j cap plus 2k cap. So here we have the vector AB. We're going to label this as number 1. Next, we will try to find out the vector BC. Now, BC is formed by joining the points B and C with a vector going from B to C. So, in terms of the position vector, it's simply OC vector minus OB vector. The OC vector is 7i cap minus k cap, and from here we're going to subtract OB vector, so that's negative 2i cap plus 3j cap plus 5k cap. This will be equals to, we have 9i cap, then we have negative 3j cap, and then we have negative 6k cap. Now, however, what we'll do, we will try to simplify BC vector. So let's take negative 3 as the common factor. So if we take negative 3 as the common factor, so we have negative 3 multiplied to negative 3i cap plus j cap plus 2 times k cap. The reason why we took negative 3 as the common factor, because now we can express the vector BC as negative 3 multiplied to the vector AB, which means that we have BC vector equals to lambda times AB vector, where we have considered lambda to be some scalar with a value equals to negative 3. And whenever this particular criterion is met, this simply tells us that the points A, B, and C are collinear. So we have verified our problem. So it is indeed true that the points A, B, C, whose position vectors are given to us, these 3 points are collinear.